In the previous lesson, we talked about arithmetic sequence. Now we are going to introduce another type of sequence which is called geometric sequence. In geometric sequence, every term is the previous term times a constant. This means that if I have a sequence, let's say starting with 1, then if the constant is, let's say, 5, then I'm going to multiply 1 by 5, I get 5. Then the next term is going to be 5 times 5 is going to be 25, and the next term is going to be 125, and so forth. This is what we call a geometric sequence. The constant in a geometric sequence is called a common ratio. In an arithmetic sequence, we said the constant is common difference, but in a geometric sequence, we call it common ratio. And to find the common ratio, take any two consecutive terms. Let's say in the previous example, let's say 125 and 25. Divide any term, 125, by the previous term, which is 25, and you get 5. Or take 25 and 5. Divide 25 by 5, you get 5. Take 1 and 5. Divide 5 by the previous term, which is 1, you get 5. And you can see that the constant, which is the common ratio, is going to be the same, which is number 5. So in a geometric sequence, as long as we have the first term and the common ratio, you can find all the terms in that sequence. If the first term is a and the common ratio is, let's say, r, then the next term is a times r. The term after that is ar times r, which is ar squared. The next term is going to be ar squared times r, which is ar cubed, and so forth, until, let's say, the last term, the nth term, which is going to be ar n minus 1. Now the last term that we found was a times r exponent n minus 1. This is what we call the explicit formula. So the explicit formula for a geometric sequence is Tn is ar exponent n minus 1, where n is the term number and starts from 1. The first example says, look at the following sequence and determine if it's an arithmetic, geometric, or neither. First, we are going to try to see if it's arithmetic. In arithmetic, the difference between the terms is the same. 5 minus 2 gives us 3. 10 minus 5 gives us 5. So we know that this is not arithmetic. To see if it's geometric, we divide every term by the previous term. So 5 divided by 2 gives us 2.5. 10 divided by 5 gives us 2. You can see that these two, 2.5 and 2, are not the same, so this is not geometric. So the answer to this question is neither. The next one is the sequence 0.2, 0.02, 0.002, 0.0002. Again, to check if it's arithmetic, we are going to find the difference between two consecutive terms. So 0.02 minus 0.2 is going to give us negative 0.18. 0.002 minus 0.02 is going to give us a negative 0.018. You can see that these two are not the same, so this is not arithmetic. Now we are going to find the ratios. So we are going to say 0.02 divided by 0.2 is going to give us 0.1, and 0.002 divided by 0.02 is going to give us the same 0.1. Since the ratios are the same, we can say that this is a geometric sequence. Of course, you have to also check that 0.0002 divided by 0.002 is going to give you 0.1, which in fact is going to give you 0.1. So this means that this is a geometric sequence. The next question is a plus 2, a plus 4, a plus 6, a plus 8. First we check if it's arithmetic sequence, so we are going to say a plus 4 minus a plus 2, which is previous term. I get a plus 4 minus a minus 2. A cancels out, so 4 minus 2 is 2. Now I'm going to check the next term. A plus 6 minus a plus 4 gives me a plus 6 minus a minus 4. A cancels, so I get 2 again. I can also try the next term. A plus 8 minus a plus 6 gives me 8 plus 8 minus a minus 6, which is going to be 2. Since the differences are the same, this is an arithmetic sequence. In the next example, we have the explicit formula for a sequence, and we have to find the first 3 terms of each geometric sequence. The first one is fn is 5 times 3 exponent n minus 1. So the first term, f1, is 5 times 3 exponent 1 minus 1, since n is 1. 1 minus 1 is 0, 3 exponent 0 is 1, so I get 5. The next term, f2, is 5 times 3 exponent 2 minus 1. 2 minus 1 is 1, 3 exponent 1 is 3, so I get 15. The next term, f3, is 5 times 3 exponent 3 minus 1, which is going to be 2. 3 exponent 2 is 9, 9 times 5 is 45. The next example is t sub n is equal to 16 times 1 over 4n minus 1. Again, t1 is 16, 1 over 4, 1 minus 1n is 1. So 1 minus 1 is 0, 1 over 4 exponent 0 is 1, so I get 16. T sub 2 is 16 times 1 over 4, 2 minus 1 is going to be 1, so it's going to be 16 times 1 over 4, which is 4. And T3 is 16 times 1 over 4 exponent 3 minus 1, which is 16 times 1 over 4 exponent 3 minus 1 is 2, so 1 over 4 exponent 2 is 1 over 16, so I get 1. The next example, the first term is 125 and our common ratio is minus 2. So the formula for the nth term by definition is a r exponent n minus 1. A is 125 times r, which is negative 2, exponent n minus 1. So the first term, t1, is 125 times negative 2 exponent 1 minus 1 is 0, negative 2 exponent 0 is 1, so we get 125. The next term, t2, is going to be 125, negative 2 exponent 2 minus 1. Now 2 minus 1 is 1, so negative 2 exponent 1 is negative 2 times 125 is negative 250. And the third term is 125 times negative 2 exponent 3 minus 1, which is 125 times negative 2. 3 minus 1 is 2, negative 2 exponent 2 is 4, so it's going to be 125 times 4, which is going to give us 500. The next question says, determine the number of terms in the geometric sequence 4, 12, 36, and the last term is 29, 16. Since the geometric sequence, it is a fact, we know it's a geometric sequence, we can find the common ratio. First, the first term is 4. The common ratio R is any term divided by previous term, so 12 divided by 4, which is going to give us the same as 36 over 12, which is going to be 3. So our formula becomes A, which is 4 times R, exponent n minus 1. But we know that this one is 29/16. Now I'm going to divide both sides by 4, and I get 3 exponent n minus 1 is 729. Now I can either try to express 729 as 3 exponent a number, or I can use the log function. Let's use the log function here. I can write this, if I take the log of both sides, I get the log of 3 exponent n minus 1 is log 729. Log of 3 exponent n minus 1 is n minus 1 times log 3, which is log 729. Divide both sides by log 3. I get n minus 1 is log 729 over log 3. I move negative 1 to the right, I get n is log 729 over log 3 plus 1, which when you simplify, n becomes 7. The next question is a word problem which says that introduction of seat belts in Canada has reduced the number of deaths in collisions. Now, from 1984 to 2003, the number of deaths decreased by about 8% every 5 years. The number of deaths at 1984 was approximately 4,100. So we know that we are dealing with a sequence. First is geometric, because every year it decreases by 8%. So this means if the first one at 1984 is 4,100, 5 years later, which is going to be 1984 plus 5, 1989, the number of deaths is going to be 4,100 times 0.92. Remember that every year it decreases by 8%, 0.08. So 5 years later, it's going to be 1 minus 0.08, which is 0.92. So it's going to be 4,100 times 0.92. And the next year is going to be 4,100 times 0.92 times 0.92, and so forth. Now we are supposed to find a formula or an explicit formula to predict the number of deaths for any fifth year following 1984. So we say that Tn is the first one, which is 4,100 times 0.92 exponent n minus 1. N is the number of 5 years following 1984. Now it says write the number of deaths as a sequence for 5 5-year intervals. Okay, the first term is going to be 4,100. The second term is 4,100 times 0.92, which is going to be 3772. The next one is going to be 4,100 times 0.92 exponent 2, which is going to be 3470. The next one is 4,100 times 0.92 exponent 3, which is going to be 3193. And the last one is going to be 4,100 times 0.92 exponent 4, which is going to be 2937.